One thing that we have is we do have different concentration units. So one that we are familiar with, molarity, right? Big M. This is where we're going to see the amount of solute. Okay, so that's basically the amount of solute over our volume of solution. So moles over liters, right? Moles over liters. That's molarity, right? The units moles over liters, right? Moles over liters. So we know about molarity, okay? But let me introduce you guys some new ones that we're going to be covering. Okay, molality, that's small m. Okay, molality, pretty similar, right? But you do not want to get these confused, right? Because they got m's, they basically sound the same. Molality, molarity, one's a big M, one's a small m. But the key difference between the two, right, is that molality is the amount of solute in moles. So once again, still in moles. However, look at the bottom half. The mass of the solvent in kilograms. So notice, right, molality is not only, it's not in a volume, right? It's in a mass. Okay, so it's a mass of the solvent, not solution or anything like that, just the solvent in itself in kilograms. So moles over kilograms. That's the key difference between molality and molarity. We got the volume on the bottom, but we got a mass over here. We also have mole fraction, right? You see this symbol, that's our mole fraction. No unit, but basically mole fraction is the amount of solute, so in moles, right, over the total amount of solute and solvent in moles. Okay, that's the mole fraction. This is exactly like a fraction. Okay. We also have mole percent. So this is the amount of solute in moles over the total amount of solute and solvent in moles. Very similar to a mole fraction, however, you just times it by 100, right, to get to that percentage, right? So mole percent, mole fraction. All right, we also have parts by mass. So parts by mass is basically we're going to have the mass of the solute divided by the mass of the solution. And depending on this, right, you just multiply by that certain factor. So say you want a percent by mass, okay? You're looking at a multiplication factor of 100. All right, so this is percent by mass. But if you want like parts per million, okay, so you kind of see these with the environmental things or something like that. Parts per million is basically timesing that by 10 raised to the 6, right? Million. Parts per billion, you just times it by 9. So basically, if you were looking for parts by mass, you would just do, say for instance, parts per million, mass of your solute over the mass of your solution, and then you're going to times that by 10 raised to the 6. That will give you your parts per million. And then we also have parts by volume. All right, so the main difference between this one is that it's just in volume. So instead of taking the mass of your solute in solution, you're just taking the volume of your solute and the volume of your solution, okay? And then multiplying by that factor. So for different, there's different reasons why we use all these, okay? But at the end of the day, we just have to understand that these are just concentration units. These are just concentration units that are just telling me how concentrated something is, okay? It's just giving me that unit that I need, that number value that I need to see, okay? And then for some instances, right, it might be better to use parts by mass, or it might be easier, right, to use parts by volume. Same thing with molarity versus molality. There will be some instances where molality makes more sense to use than molarity.